Welcome back. Let's take a look at our final lesson in this storage optimization module. This is monitoring storage activity using ESXtop. In this lesson, we will determine which disk metrics to monitor, identify metrics in ESXtop, and demonstrate how to monitor disk throughput. So, where could storage problems occur? Well, there's been a lot of things that we were covering, especially in that first lesson, in areas to be mindful of, right? We need to be looking at queuing. We need to be looking at LUN configuration, potential network configuration. But then what metrics should we be looking at from which perspectives? There is problems could arise from the VM to its virtual disk, could be through the HBA or through the network adapter, could occur at the device level, whether that's actually at the physical switches or at the storage switches, storage processors on the array side, or maybe even the actual storage devices themselves. So we have several perspectives that we need to be mindful of, and ESXtop happens to show 3 different perspectives in storage monitoring, from the VM, the adapter, and the storage device perspectives. So we can identify these problems using ESXtop. So the storage key performance indicators we list here. Effectively, it really, in a lot of cases, depends on what your application requirements are, especially when it comes to the first one, disk throughput. This is usually measured in things like megabits per second or megabytes per second. Actually, if it's storage, it'll be in megabytes per second or maybe kilobytes per second, depending on how you like to measure your storage metrics. But ESXtop reports things in megabytes per second. So that tends to be a standard way to measure. And we can measure your data rate in throughput by megabytes per second reads and megabyte per second writes. We also can measure latencies. And the latencies are important because they tell you where the problems are likely located. I like to call the latency metrics the finger pointers. They'll tell you, okay, the problem's in your host or the problem's outside of your host. I mean, that's usually kind of the long and short of it. It's either in the host that's got a bottleneck or it's somewhere outside of the host. ESXtop can tell us that much, right? The ESXtop isn't going to tell us it's in your switch or it's in your array or it's in your LUN. Well, no, the ESXtop will tell you the problem is outside of the ESXi host. It's now up to the storage troubleshooting tools that you might have to inspect what's going on outside of the host. But we can tell you what's going inside the host. And in fact, these metrics will tell you, we break them down between what are called device latency, kernel latency, and so on. Then we can also look for much more serious issues like aborted disk commands, right? And compare that with active disk commands and commands queued. In fact, what you'll find is that the queued items will probably be the precursor to flat out aborted commands. We don't want to see any aborted commands. That's a complete overloaded storage. So let's take a look at some of the different things that we can monitor. From the 3 different perspectives inside ESXtop, we have the adapter view, the device view, and the VM view, right? Now, how do you remember all the different keystrokes? Well, the letter D is the keystroke that'll take you to the adapter view, right? Hit the letter D and you're going to see adapters down on the left-hand side. So you're looking at from the perspective of the adapter, and you will be able to see all kinds of metrics such as the IOPS per second, right? Commands is what it's actually showing, but it's really IO operations per second, and breaking it down between reads and writes for each of the different adapters. It also show you the throughput, the megabyte reads and megabyte writes, telling you in a data rate perspective. You can compare this on a per adapter perspective. Now, important thing to note here is that while this is showing you metrics across all the adapters, take a look at this column right here, NPTH. That stands for number of paths. Sometimes it's useful to find what's going on at the adapter, but maybe there's actually a specific path that's going through the adapter that's having an issue. So it's something that you can do here. Whenever you see these numbers that are plural here, more than one, you can expand on these values. Just like we were able to expand on VM worlds when we were looking at the CPU screen, we can expand on our paths when we're in the adapter screen. So it's the same keystroke. It's the letter E. You type in the adapter you would like to inspect further on, and then it will open up all the paths for us on that one adapter. So we see there's 10 paths. And then we might be able to find out which of the paths seems to be, generating all the activity per se. Now you look carefully here. There's probably just 2 LUNs that we're working with, and there's just multiple paths for each of the different LUNs. But how do we know that? Well, here, what we can do is we can actually reverse engineer some of this information to find out which actual data store does this actually relate to. what you can do is, first of all, you probably already have an idea what data store is having the problem. You'll find that, with customers complaining or users complaining in their environments. So for instance, what if we wanted to look up a data store like this one, Opscale Data Store? That's in our iSCSI SAN. So we can first click on the data store, find its configure page, and then under device backing, you'll find the actual SCSI hardware address. I can search for that in ESX Top. Now, this is easy because we have a small environment. I know an environment where you have hundreds of LUNs, this is more challenging, but at least what you'd want to be able to find are maybe the last 3 or 4 digits of the device ID so that you can just search for that in the output of ESX Top. So another way of finding this, by the way, would be by drilling down to an adapter on one of your ESX servers and finding the storage device this way too. And in fact, this way will help you find the LUN ID. So if I knew that, for instance, this was ending on the name 579 something, we can find that other, in the same adapter here, and here it ends with 5795, and that happens to show us it's LUN 5. And there it is, it's the Opscale Data Store. Also, you'll note that there's also a LUN 0. So we just see there's 2 LUNs here. I know, not a big environment. So if I were to look at the ESX Top using the LUN or device view, that's the letter U. I like to think of it, the letter U for LUN, right? D for adapter and the letter U for the LUN view. It shows you everything too. It's not just LUNs. It'll show you local attached disks as well. But here we see that there are our 2 LUNs that are on our iSCSI data store, and they're the one that we're looking at here, right? The 5795. And we can gather the same basic metrics at the LUN perspective. We have total I/O operations, reads, writes, separate out from the I/O operations, and then megabyte reads, megabyte writes. You get all the details on the LUN level. And in fact, if you take a closer look, there's actually another way to expand those details. You can expand LUN views based on the path, the world, or partition. If you select the letter capital P, it'll break it down by path. So again, now we're actually showing the 5 paths for the one LUN, as opposed to the adapter view, which was showing you all the paths going through that adapter, which was basically all the paths to all the LUNs. Here we're looking at the 5 paths that are available to this one LUN, LUN number 5. And sure enough, there's a path that's getting all the activity, right? And the actual data rate on that. So you can get very detailed information in these different reports. Similarly, we can also do this for our VMs. In the little V view, you view the VM's access to the virtual disks. And we get the same basics. We get the number of I/O operations, the reads and writes broken down. We can see we're doing a lot more writes than we're doing reads. And the actual data rate, so 158 megabytes per second. So maybe it's this VM writing, and that's causing the activity down this one path that we're able to see and kind of glean from the different reports. But wait a minute, this VM might have more than one virtual disk. In fact, if we look over here, there's NVDisk, telling you how many virtual disks that are actually a part of this VM. Is this VM working with all 3 of its virtual disks and causing all this extra I/O activity? Or can we find out which virtual disk it is? Well, with the letter E, once again, we can expand on the VMs, and this time you expand based on the VM's group ID. So now we're going to grab the 57941, which happens to be the Linux 01, and we'll break it down by each of the different VM's virtual disks. And we can find, now that they're all zeros, but it would be useful to see, oh, it's this virtual disk, right? The VM has their boot drive on SCSI 0:0, but maybe he's got an application drive and a data drive, and you can see which is the one that's actually causing all the I/O. So you get a lot of information through monitoring the data rate and the I/O operations through each of the different perspectives. Next up, we're going to take a look at latency numbers, but we'll take a quick break and we'll come back and finish our lesson at that point. So we'll see you in a few minutes.